Okay, sorry for the delay. I changed a lot of things with my settings, and I learned nothing. I erased all the changes I made out of frustration, put it back to the way it was, and now it's working. So, good thing that it's working, bad thing that I learned zero. Um, the issue was I was hearing it every time through the headphones I'm using, and I don't have an easy way to indicate whether or not it's coming through in the video without pulling up this window. We'll verify this time. And in fact, it is working. So sorry about that. That was probably a little awkward at the beginning when I kept hearing things, assuming you heard the same thing. But in the spirit of doing this live, none of that sound earlier was important. And if you're following along in the code, you would have gotten the same result. So I'm leaving that the way it was. It's just a few clicks and pops, some noise. So I'm leaving it. All right. Moving forward. So now we verify that we have polyphony. Let's go ahead and see if we can end the grains. So the duration is... so what we want to find out is if the phaser moves from 0 to 1, gets to 1, goes back to 0, we will want to stop the sound file. So let's do that. So right now we're still not applying any form of window or envelope. So it'll be kind of inherently a rectangular envelope. Let's go ahead and in our process function do phaser process. And one trick we can do to find out if this phaser went to the end of its period is to make a float called previous value. Okay, so after we do all this, we can get the current value of the phaser, and at the end of this process, we'll do phaser current value. We'll set our previous value to equal this. All right, so what we need to see is if we subtract the current value from the previous value, no, if we subtract the previous value from the current value, if that's negative, so if that's 0, if a perfect edge, if it's 0 minus 1, that'll be negative 1. So if this value is less than 0, we know we've gone across that edge. So all right, so what this means is if phaser get sample, so our current phaser sample is less minus our previous value, which is the sample of the last process function, is less than 0, in this case, we will tell the grain to end. So I have a function for this. We could just say alive equals false, but we do have a function. So let's call that function. What did I call it? I think it's end. All right, let's see. So what should happen is this will pick a duration from 5 milliseconds to 200 milliseconds, and after that time, it will end. And so we should only really hear one grain at a time, since these grains are being emitted every 250 milliseconds. We'll have varying grain lengths. Okay, so we also need to set current sample to 0. That's not correct. So we could hear that the clicking changed frequencies depending on the duration, most likely. When this ends, it's just allowing this grain to be reused. You know, one thing we should do is we're going to always try and process every grain, but we really only need to do any of this if the grain's alive. Oops. If it's not alive, okay. So that fixed whatever. I don't know exactly the issue we're having, but moving right along, we don't need to solve that at the moment, so let's save some time. Here we're getting these grains. They're all starting. It seems to be correct. We might be having some burst masking. Can't quite tell. It could be the amplitude. Let's just do amplitude equals 1. It could be the location in the sound file as well. Let's do the duration is longer as well. Just trying to narrow down the problem. So the problem we're having is it seems to be not playing every single time. Every once in a while it won't take, which is strange. Huh. So we listen to the impulse generator. I think we're getting those impulses. We checked that at the beginning. Let's go ahead and increase this to 15, or I guess 16, and that way we can test this a little more quickly. So the impulse is being processed. I'm just making sure we're never setting the pulse deviations here. We never set burst masking. Burst masking should be set to 0 at the beginning. Perhaps it's not. Burst masking 0 to 1. burst masking equals 0. So that is correct. That's what I would expect. So it's not that. So we have our position. Which we didn't use that. That's my mistake. But I'm setting it halfway, so the position's the same every time. The speed is between, I mean, I can't imagine it's too low to here. Let's change this back to amplitude so I don't forget. Let's just make it non-random. It's going to be 0.5 every time. The speed, let's just make that 1. Oh, for the position, we just didn't implement this earlier. It should be between 0 to 1 if it wants to start at any random location. Let's just make it 0.5 to 0.5. It will be 0.5 and take care of that. That's the same as it was. Speed set here. Perhaps the we should set the phase before we set the frequency. I don't think that would cause that. Oh, these are going to be all very, very overlapping. This will be hard to tell. Duration, like 20 to 30. Yeah, see we have this. That is a really bizarre issue. Live equals true when it starts, of course. If it is alive, it processes the current sample, gets sampled. We're starting same index, we get it from the same spot. The amplitude is always the same. So if narrowing down the issues, that could possibly be true here. Current ith phaser, so it's edge detection. So when we start the grain, let's set previous value to 0. Maybe that's being left at 1. Oh, yes. So I think this grain gets killed before it can exist. All right, so if this grain started, this previous value was maintained at 0.5. All right, I think we found it. It would be negative at the very first time and then immediately killed, and no sample would ever be made. Okay, I am satisfied. There we go. Alright, so that was strange. Alright, 4 grains per second now. Let's change these values back. It can be from 0.05 to 0.5. The speed can be from 0.5 to 2. The duration can be 220 to 200. Position 0 to 1. And then everything else is groovy, I think. Okay, satisfied. I'm also going to verify that you guys are hearing this. Okay, great. You guys and gals. All right, so there we go. So we have confirmed that we have varied duration that's being based off of a phaser. You might be wondering why I'm using a phaser to do that at all, if we had to do a little bit of trickery here to find out when that phaser has reached its peak. And the reason is, when we're using a window function, I made it a little more efficient by making it 0 to 1, so we don't have to do a division every time when we do that calculation. Then that's inside the code. So what we want to do now is find our handing window, and I forget what I called that actually. So let's use, I think it's a generator. Windows. Okay, so we have hand window and phase. So this will be 0 to 1. Alright, so our amplitude will still be the same, but we'll also scale it by where we are in the window, which will be very easy since we have that phaser set up already. So we're multiplying it by the amplitude, but we also need to multiply by our window location. So hand, window, phaser, get value, or sample. All right, and so that should immediately apply a handing window, which is great. Let's go ahead and verify. We should get rid of those clicks and pops now. Okay, great. I'm going to go ahead and just for a quick reference, handing window. Not MATLAB. Get away, MATLAB. Nothing against MATLAB. I haven't become close enough friends to know that I hate it yet. Here we go. Here's a picture of a handing window. So you could think of windows in this case just like you think of an envelope. It's just affecting amplitude over time. So when our grain starts, it's completely silent. As the grain progresses, it's loudest in the middle and droops on back down. I like the handing window. It's very clean, very neat. I use it very often. It's a personal favorite. There's, we could use a triangular. You can look through that page if you'd like. You can experiment with different windows. I made the functions all the same. So if you want, if you're sitting at your computer, you can go to the folder here, windows.hpp, and try any of these windows. Cosine window works well. Triangle window works fairly well. Handing windows are, we look at this graph there, leave it open. It's the quietest, and by that I mean it will. If you have a periodic stream of grains, you'll start to hear this as a sine wave. If you imagine these back to back to back, you'll end up getting sidebands from that amplitude modulation. So that is more prevalent if it has sharp turns. If you do the same thing with a triangle window, those sidebands will be more noticeable and more annoying. So I tend to go with the handing window. But go ahead and experiment. There's a lot of different windows there. It just gives a different contour. Let's go back to our project. All right, so now what we can do is increase the emission rate. Let's do 40 grains per second, just for a little fun here. And yeah, we can leave that grain the same, and we can make this even more dramatic. Let's do 0.5 to 4. Okay, great. So we are kind of doing I think what I've found so far to be the simplest method of polyphony here, which is just doing all of the time. We are doing one thing right here. If it's alive, we're processing it. We are still calling the process function even if it's dead, but it's not actually calling any of this this information. It's not calculating the position in the handing window. It's not grabbing the sample. It's not processing the phaser. If it's dead, it's just returning 0. So that's and again, this happens. This happens here. What's going on? Oh, sorry. Here we are. This happens here. Grains that process. This is processing all 128 grains, and we could, if we wanted to. Yeah, let's actually do that. When we were calculating density kind of, well, not kind of, it means how many grains are currently active, regardless of how loud they are, which you can make your own metric for that. But let's make a quick function. In our grain file here, we'll need, we already have get alive, so we're not taxing our computer too much anyway. So for I is less than max grains, increment I. So let's make a value int n equals 0. If grains at I get alive, so if that grain's alive, we're going through every grain. If that grain is alive, in increment n, add 1 to n. After we've gone through all of them, we'll see out n line. Let's make this a little better. Number active. Very nice. And we'll put a space there. All right, and then after we print it, we can go ahead and set, and it'll go back to 0 anyway. So this, every time the frame updates, so this is vertically synced, so we'll get 60 a second. We'll know how many grains are active. Note that I put this in the update, or I could have put it in the draw function. Either way would have worked. But I did not put this in the audio thread. Don't use cout in the audio thread if you can avoid it. You can avoid it. Don't do it. Or just do it knowing that you're going to destroy your audio thread. I do it occasionally when I'm feeling lazy. A better way would to be like make a document and just print it to that document and save it at the end. Perhaps I'll add that to the library. It really needs to be a better way to troubleshoot your audio thread. Like actually print out information and find out what's wrong. cout will not do that well. It ties your thread. It will not continue until that function is completed. In the audio thread, you can't do things like that. You can't block your thread. So anyway, so I have access to this information, so I can find out how many grains are active in real time. Great, so that's pretty straightforward. So let's make a little bit of control here. I don't think we've used GUIs in this tutorial, and this tutorial, or walkthrough I guess, is not about GUIs, so we'll just jump right on into it. It is included, correct? Yes. All right, so ofx, I think panel, we'll call it GUI. ofx float slider, emission rate. All right, now let's see if this turns green for us. I may have to look this up. I'm going to go ahead and keep going. Okay, it's happy, and float slider, I'm almost positive is fine as well. So I'll move over here. All right, GUI.setup, GUI.add. We'll add our float slider, which we call it emission rate. Well, let's go back. good. Set up. We'll have to give it a name. Emission. A starting value, which we'll do 40. Our lowest value is 1. And our highest value, let's just go crazy. Let's do 1,000. No, that wouldn't make sense. Our max is 128. Let's do 100 as our maximum. Whoa. I love that autocomplete. It's always really helpful. Okay, so what's it upset about now? Oh, I did. Thank you. I take back what I said. I was being mean. All right, so I don't recall if we have to update it. Let's draw after the sound file. I'm going to go ahead and see if it will let me update it. Up. Nope. Nope. Okay, good. So I think it's fine. And I'm just, that's not controlling anything yet. I'm just going to verify that it works. No, not works. It just displayed. Okay, so let's attach it. This is very easy in this GUI library. We can keep printing that if we want for now. And let's set, let's see, what is it called? Impulse. So our impulse generator, we'll set the frequency to emission rate. So you can just use the same name that you called the slider, and that's where it stores the value. So that's all taken care of. So now we can actually actively control the rate of emission of these grains. All right, so you can see the number of actives constantly updating. Let's go crazy. The number of active doesn't... Oh, yeah, 100 would make a 10 millisecond average, or period between, so that we can actually increase this. Let's just add a 0 here, run it again. Okay, so one thing to note, we are getting this. Yeah, there we go. All right, so it turns out that we can't do 128 simultaneous grains. This is stream over/underflow detected. I can't imagine what an overflow is, honestly. But an underflow is we can't get enough data in the right amount of time. So you heard those clicks and pops that happened. That was not audio clipping. That was our audio thread not being able to manage the job, which is fine. That's a lot to ask it. 128, and it seems to be happening. We can look around 109, 110 simultaneous grains. Yeah, we hit close to our max, so we can adjust. So 128 is a lot, and we're not, going too far out of our way to make this efficient. But I want to set this to 64. My original plan was 32, so we're still doing all right here. And what happens? Note that if we reach our max, we are at max capacity. When we get a new impulse, it'll just totally ignore it, which is, completely fine. That's, I think, a reasonable way to handle it. If you're dealing with MIDI notes, there's a whole school of thought There's several schools of thought on how to handle voice stealing for certain situations. Like a monophonic synth obviously only has one, but when you are polyphonic, sometimes if you reach your max, you might do a voice stealing thing. So you quickly fade out the oldest note or the quietest note, depending on who you ask, and fade in the new note as soon as possible. That's super complicated, and when you're dealing with a grain, they have fade out and fade in time. The grain is already alive and dead within that duration. So this is an easy method. Just when we're going through this loop to make a new grain, if it gets to the end of the loop, nothing happens. It just continues this loop. It checked every one and just moves along. So we just don't get that new grain. So fantastic. All right, since we've added the GUI, let's just go ahead and make a GUI for every controllable parameter that we want. All right, we have emission rate. I noted that we'll want amplitude, duration. We'll call this center duration. I should call these all center amplitude and center duration, because we could go randomly above or randomly below, but the stochasticity will be added later. Duration. We'll have an index location x. This seems dangerous. Let's just do location. Fx float slider y location. So this will be the crossfading between sounds, which we only have one right now, but we will get to that. You know, we could have. Nah, I was going to say we could have two GUIs, one for the right hand, one for the left hand, but that's not really helpful. I guess it looks nicer, but the GUI is not going to look nice with this library. That's just a fact. Nothing against the thank you for making it. If you're watching this and you develop the library, it's amazing and handy, but that's not what openFrameworks is about. Slick GUIs are for other software environments. Until someone makes one. But it's not going to be me. At any rate, we talked about having a reverb send. We'll add that later if we decide to. But we do need we'll call this left open. So how open our hand is on the left hand, and if float slider right open, how open our right hand is. And these parameters will control several other parameters, or these sliders will control several parameters. All right, so this is just a little bit of tedium. I'm going to copy and paste this so I get this all right. Go to our setup function. These are in no particular order. Amplitude.setup. We'll start at 0.7. Sure. I'll go from 0.0 to 1.0. Let's see, reasonable values for. Well, one thing I'll note is these sliders are going to be linear, which is fine. Let's do 100 as the starting point, 20 as it's granular synthesis. Let's get weird. 0.1 as the lowest duration, 0.1 milliseconds. That's short, and 200 as the max. X location. So this is our index location on the x-axis. Let's just do 0.5, 0.0, 1.0. Y location will be a little strange. Let's think about this. So we'll have 4 sound files. So it should be 0 to 3, I think, is the most logical way to handle this. Let's start in the middle. So 0, 1, 1.5 would be the middle. I shouldn't say that as a question. 0 and 3. And these things in quotes are just what's displayed on the slider. Let's make this a normal. I like that. 0 to 1. So we'll start 0.5. Actually, let's start this one not open at all. Same thing with the right hand. Okay, so those are added to our GUI, and I mostly I just use the GUIs to for quick prototyping, and this is obviously very quick because we're going to eventually add the leap motion. I'd like to do that last. I'd like to make sure every part of the synth is working, and we can just click and drag and experiment. It's really hard to hold your hand in a specific location constantly to experiment to make sure that your variables are actually doing what you want them to be doing. GUIs are really good at staying exactly where you leave them. Okay, so we just have a list of floats, and you'll see that this just adds them vertically to the slider panel. Okay, so now we'll have to consider how we're going to get these data to the grain file. Getters and setters. Oh boy. All right, this is going to be real tedious. But we'll make it. We'll make it. Actually, I'm going to take a break, have a cup of coffee, and I'll be right back. Thank you.